Welcome to Vision and using your Limelight or Gloworm. We're going to review some new hardware that's kind of new to the market this year for beta testing. My name's Corey Applegate. Yeah, click over here. I'd like to first off thanks Medtronic for hosting these events, along with Delta ModTech 2 weekends ago, and well as this weekend, St. Cloud State University for hosting this event. Typically, we'd be here this weekend with nearly 1,000 students on campus, but with COVID and the way the world is today, we're doing everything remote. So thanks for everyone for joining this. These recordings will be put up on our jumpstartrobotics.org website as well as our YouTube sites. So if there's any need to watch because you're in another room, please check out these web pages and review them and pass them on to other people on your teams. Again, my name is Corey Applegate. I'm here today to show you a little bit about some vision systems out there. A little bit about me, nothing new there. I've been in the industrial automation for over 22 years. Coached Lego robotics for 4 years. This is my I was part of the Limelight beta team originally, and a lot of these Limelights that you'll see in front of us were given to us during that beta testing period. So I just wanted to disclose that, as well as the Gloworm that I have in front. We were part of the beta team on that, but we did purchase the cameras from them on the early purchase. Today, if chat moderators, Justin Fisher, Carter Calhoun, and Zach Osplung, they are all alumni. Zach, did I say your last name wrong? You chuckled. Asplund. So getting right into it, we have a couple quick slides, and then really this whole presentation is going to be live demonstration of the different hardware. And I do want you to cut in and I don't hear anything other than, or I won't hear myself, will I? So no, I don't want to hear myself echo. So anybody want to cut in, you can ask your questions as the presentation goes. And this is really meant to be one-on-one or one on the group interactive talk. So put your questions in the chat. We'll get you pulled up here and we can try to perform or demo any questions you may have. So there's a bunch in First Robotics. There's lots of different camera options. And over the years, I have a couple things in front of me here. There are Pixie cameras, the JAVO teams have tried to use, as well as a lot of the USB cameras over the years, and the Gloworms and the Limelights. I have a couple different versions. So several years ago, we had our Limelight V1, which we were originally on the beta team well, and then they went to the V2, nice smaller package, still as powerful, and everything is backwards compatible. And then this year it was just introduced to this just 3D printed beta version of the Gloworm, and we're going to look at that, how that hardware works. Teams also, and last week, Green Machine did a presentation on vision processing where they'd use a board similar to the NVIDIA. What is that board? The NVIDIA boards here. We have never used one on our team, but in the past, this tabletop of different things we've used is the Kangaroo mini PC attached to an IP camera, needing a power supply. So lots of different hardware that you need to put on your robot to get a vision system working. When the Limelight came out, it was kind of revolutionary, where it was all in one package deal. So, and everyone has their own benefits and disadvantages. Cost being a disadvantage is probably, but ease of use comes with the higher cost. What was that? It froze over here too. So as they fix the camera, okay, so first thing we're going to look at here is the Limelight. 2 more slides here and then we'll get into the live demo. Nice thing about the Limelight, it is that all-in-one package. It has an internal web page that you log into to configure your network settings, adjust the sliders to filter the images out, and calibrate any crosshairs for vision tracking systems out there. It's all in one. Software's in there. It is closed source. That's what you're paying for, is that development of that vision system. New this year is that Gloworm. It's just hardware. It really replaces all that stuff I showed you just a minute ago with having a computer, a processor, a camera, maybe a power supply, having to mount a ring light and getting all these different components together. The Gloworm is a Raspberry Pi internally, but you do have to install your own software. There are lots of open source projects out there, similar to, or with Photon Vision, FRC Vision are just two of the more popular ones right now. And today I have the Photon Vision image loaded in this camera. So I'm going to go on to the demo. We're going to close this slideshow here. And like I said, if any questions as we go through, please interrupt me and we'll get those answered. So out of the box, when you purchase your Limelight camera, we'll start there. You're going to get this is one of our beta units right here. You're going to get this camera here. And the camera can be powered up over PoE over Ethernet, like similar to what we use for our radios on our robots, as well as power ports directly into it. Today, I'm just going to do PoE. What I carry with me in the pits when I'm trying to help teams is I have this cord, this PoE injecting cord that we kind of handmade. But the nice thing about this is at my computer, I can plug in and I can reach out further to plug into the radio. So that's what I have in front of me here today, plugged into these Limelights. So when you unbox your reel, or sorry, check that. When you unbox your Limelight for the first time, you plug it in there, it's going to start powering up. Now on our computer side, this is probably one of the biggest struggles is setting up IPs and getting everything communicating here. Is we want to go over and bring up our Ethernet connectivities. We want to make sure that currently our laptop or computer that we're hooking up to is set to obtain IP address automatically. Because out of the box, this Limelight is configured to DHCP. Once we have that, we need to browse to a website, and it's very similar with the Gloworm. And for the Limelight, it's quite literally limelight.local.5801. That there, if everything was loaded up right and the Limelight is found, you'll see come up to this web page here. Now, there's a big Apple versus Android polarizing discussion out the world. DHCP, not DHCP, static. I'm on the static side, so I like to go to the setting page right here and right away set all my devices to where I know they're going to be. You're going to change your team name, your team number, and that's for the network tables, as well as the stream rate, low or high, depending on if it's a bandwidth intense game or not, and how many cameras you have on your robot. These are configurable. And it's usually the stream back to your computer. You don't need a lot of resolution. Your drivers just need to see the blobs that are happening and going out on the field, as well as this resolution. We kind of keep it at the medium range here versus the low. Again, the static IP. We're going to change ours to the FRC standard, which is 10. The first two numbers of your team name, 32 in our case. Second two numbers in your team name, 44. And typically, our IP ranges that we're allowed to use for our own devices start at 11. And that's where we'll set our first camera at today here on 11. If you're going to have multiple devices, then you'll need to keep track of that, as well as a network mask. And finally, when this is on the robot, and today we're not using the robot, I'm going to show you ways to use the Limelight or other camera systems without having a robot present. But you would want to go ahead and hit this as well and set this to the router IP using the FRC naming convention of 10.teamname.1 would be the radio on our robots. Once we get to there, we can hit our change IP, and a power cycle is then necessary for our Limelight. And I'm going to move on to one of the other pre-configured ones, because what we're going to start doing right away, and this is what we do on kickoff, is we bring this cable along with us, our Limelight along with us, and a blank board along with us to start doing vision tracking right on kickoff day. It was last year at kickoff, we were tracking that last year's goal or target. I'm going to keep this centered whenever I do anything. About 15, 20 minutes after kickoff, we got back to the classroom, started tracking. we go to the Central Minnesota Robotics Hubs kickoff. There was 20 teams that stay there afterwards, and everybody wanted to know how far can the Limelight see that target. So once we have that IP set, we can go to the same site. In fact, hold on, there's one thing we have to change. Since we do not have a radio, we're connected directly to the Limelight with our laptop. We will need to now set our driver station or our programming laptop to the static IP. Using the same naming convention, 10.team. Now, typically in a live event, you set your driver station to a 5, and we set our programming laptop to a 50, just so it has that similar type of naming structure. But today, for this demo, I'm going to set it to 2. 2 is what is normally assigned to your robot. And since we do not have a robot here, we still want to be able to look at that network table. And all these devices here use the 10.team.2 as the network table's server IP. And then 255.255.255. And again, if this is our driver station and we were going to be on our robot, we may want to set the default gateway, especially if we're hooking to FMS, but today that won't affect us any. Once that is changed, we'll be able to go ahead and browse back to that site. It found it, didn't it? And sometimes closing Chrome so it can update its IP addresses. There we go. You're gonna be presented with this here. And as we can go look at that settings tab, everything is configured as I had it in that beta unit that we had. So right away, we can start looking at some of these settings. What's here for us to work with? We see across the top here, pipeline is grayed out right now because right now the camera is obeying whatever might be on the network or the network tables. We can rename our pipelines, as well as we can go ahead and hit ignore it. So that way we can switch around. Now, real recently, people started getting really annoyed by these super bright green lights on the field. So they're saying that we need to run with our lights off unless we're going to use our camera. There is a driver's mode, and we'll go look at that here in a little bit on the network tables, that would automatically shut lights off and turn your cameras so you can use it as a live image. But what we typically do is set our pipeline 0 to that. So there's a little less programming to do. So I'm gonna go ahead and shut these LEDs off just because pipeline 0, we might call drive mode. And that way, as our program's running and we're switching between different pipelines, maybe there's different targets that we need to see. We can switch between pipeline 1 being our primary vision target and pipeline 10 or 0 as our drive mode. These exposure levels are really used for image tracking. So we're not going to use anything else here. To get rid of some of these speckles, I'm just going to go ahead and turn off all these filters because in drive mode, we don't want to be tracking any targets. And everything is saved automatically. So what I'm going to go do here is go to our first pipeline. And what we're going to look at is, well, maybe what's this game here? I'm going to rename this. "2020 goal." Okay. Now, when we get into vision tracking our targets, the first thing we're going to start doing here is, well, obviously we need lights. So we're going to turn on our lights when this pipeline's running. And it looks like, well, our camera's upside down. So there's a few settings we can go ahead here and change our orientation because we mounted it upside down. Get everything correct. Take these out for now. Going right on down, kind of from the top down, we're setting things up. We can look at our exposure. And what we want to do is we want to turn the exposure as low as possible to still get a crisp image. So there's a lot of extra noise in this room today, a lot of extra light, so 2 all the way down. What the black level does is you can see a lot of these white objects in the background. still have a green glow to them. And what this does is really starts to dial out that green glow and really get that crisp image. So right out of the gate, we got a couple of objects in here, and we can filter out that other image in there. That's good to have that there. So now that we got a reasonably black and white image, we can go ahead and go look at the thresholding. Now during thresholdings, there's two ways about going about doing this, and the defaults that are already in here, whoever is playing on this pipeline last. I'm gonna open all these up. Just looking at all the colors. Now they give us a few different tools here where we can use an eyedropper and say, you know what, I really want to track this color right here. And you can see all those red squares that are in there. There's lots of colors missing, and we can start including more and more pixels to try to get a more solid image. Sometimes what I like to do though, I don't use those eyedroppers necessarily. I like to go into what's the manual mode. I'm going to turn all these up here and show you this other image here with thresholding. What thresholding is the pixel true or false? Is it the color we're looking for or not? We can start going from the top down, bringing up our hue, and watching until we start seeing our image that we know we want there. And if there's a lot of noise there, it's okay. Start narrowing this down. That can stay in there. Leave it in there. That's fine. Then our saturation. And it's really playing with these sliders to try to get as crisp of an image as possible while filtering out all the other garbage. And live demo is going to be a problem today with all this extra lights coming in that window. This morning, it was a little darker in the room. This is where the struggle is real. There we go. So it takes a little bit of playing back and forth, and then we got a pretty solid image there. The erosion strips, what that does is if there's a single pixel out in the open, you can kind of see some of these single pixels blinking around on the screen. You can turn on the erosions, and what that does is makes everything a bit smaller, and turn on the dilation, which just takes anything that's currently true and it grows them out a little bit just to make it a little bit more solid, less blinky image. Now that we got a pretty decent image here, we can start looking at contour filtering. And that's where the Gloworm is going to kind of come in handy right here. Since the Gloworm is open source, I've added a few tools. And those tools are going to, once we go over that, we'll explain a little bit more of what I'm doing here with these sliders here. But what we want to do is start filtering out some of these images. We can see we have two images right now and really locked into this middle one. And that happens to be the one that we're looking for. But the idea here is to make sure that this algorithm here can sort out the image and always the image from different angles. So right now we have the different sort modes, and largest does work in this case because there's one continuous contour here and the one continuous over there, and this happens to be the largest contour. But we could go with smallest because maybe that is the one that we're looking for. And what it's trying to do is find the area of all the true and false pixels. Area of the screen. Maybe there's going to be some images that we want to make sure take up half the screen so we know we're close enough to the image, or maybe only take up a quarter of the screen. And that's the total of this yellow area, the yellow box, compared to the full image of the screen. So if I start running the slider up, you can see that percentage growing up there. And basically it says it needs to be greater than 1.3% of the screen. Well, that filters out everything. So we can really filter out that, and you'll see how this works better, a little bit better with the Gloworm because I have some feedback of what these sliders do. The blue, the fullness of the rectangle. So what that is we're trying to filter out what objects we want in this blue square compared to the yellow square that's in there. Fullness of the blue rectangle. We can start filtering out and say, nope, that one shuts off that image over there. So really what today is going to be is we're going to look at lots of different images and how to filter them out. And this U-shaped image that First has given us over the last several years in Stronghold and Infinite Recharge, these U-shapes are really easy to find and filter out. And then finally, the ratio. The ratio, what that is the squareness or the rectangle shape of the box. So we can see right now we're accepting everything, but we might be able to see. I open up these other objects here, and I got a good demo here coming up that'll show us what these all do. How square things are. Direction filter. This is when we're looking for two different objects, getting a little bit more dual targets that we had last year or 2 years ago on deep space. We got some demos for that coming up. And finally on the out, so once you find your target, going through these filters, and you'll see a little bit more of how these filters work on our next little demo. We look at our output and how we want to target our outputs. So I'm going to switch over to the Limelight or the check Gloworm. Are those images in the frame there, Carter? Okay. Close this. And again, this is unscripted, so if anytime you have a question you want to break in, please do. I do plan on bouncing around a little bit, so as this powers up. Now as this powers up, we can talk about all these cameras here do allow you to install a USB camera as well as a secondary image that you can feed back to your driver station. 2 years ago, we had 3 cameras on it in deep space, very bandwidth limited game. But these these Limelight cameras have, and the Gloworm have what's called picture-in-picture, where you can bring both those cameras into one and you can flip between which one you want the main camera to be. So now with the Gloworm, since this is open source, some of the same access isn't quite as robust. This one I will have to address as the IP address, and this would work with the Limelight as well. So using our naming convention, 10.team. And our Gloworm is set up to .12. We go to 5800, and we get the Gloworm's interface. Very similar. Obviously, they are very influenced by what the Limelight does, but they have done a few other things that are unique for itself. One of the big things here is this target info. You can see right now, and now I do want that out of the way. We can see 5 images, and over here on the target side, 1, 2, 3, 4, 5 images are being identified. All of these objects are the same area. So they all have the same aspect ratio, or they're rectangles, all exactly, but with different cutouts in them. But we can see here, targets 0 through and 4 is blinking right now, so we may have to adjust some of the thresholding or exposure. Try to stabilize that a little bit. There we go. I'm allowing all items to filter through right now. So all different objects are the same area of roughly that 0.3 to 0.4, same square. Some are U-shaped, some are solid, some are boxes. The one is a square, not a rectangle, and the other one's a rectangle standing upwards. So what the nice thing about the Gloworm and Photon Vision, it is all open source. So I was able to go in there and modify the source and load up my own changes to here, because normally you'd end right here at the skew. I added the area, the width, the height, and the ratio to this target information, so we can see a little bit more of what's going on and maybe how we might want to sort out the objects. Try to get this to reorder a little more appropriate. Target sort. There we go. So I'm just kind of sorting these out. So 0, 1, 2, it's counting from the left to the right in order here. So we can see the target 0, the most left on my screen here. Again, the area is all reasonably the same. The ratio of these boxes, 0, 2, 3, and 4 all have roughly a 1.7 ratio. Or sorry, 1 and 3 have that same ratio. 1, 2, and yeah, it's still blinking. Open up some of these windows. Objects 1 or 0, 2, and 3 are really close to the same. 0, 2, and 3 are the same rectangle laying horizontally, but number 1 has a different ratio of 0.8 because it is the same area. So we can definitely look at, if we wanted to sort out number 1 and get rid of all the top row, we could go look at our contours. And really what we're looking at here is we might want to sort this one out by ratio. So anything under maybe 1.5, I might have to type that one in there. So that one sort of got rid of the hex, the rectangles, but that square is 1.2. So we have to go a little bit lower than that, maybe anything under 1. And now we are sorting out of these 5 images what that ratio filter does for us. Area, again, not much we can do in this particular, because I set these all up for area. So area in our particular filtration won't help us much here, but we can look at the fullness. The fullness, you can see the 0, 1, 2, and 4 are all over 90% fullness, but number 3 here is this U-shape. And that's what I kind of alluded to earlier today, that these U-shaped targets that they're giving us in these years are really easy to filter out. If you see a big blob of color filling the screen, what that's doing is looking at that red box, that's the area, but inside there's another box, and it's tracing the white true pixels out and trying to, with the smallest possible convex pattern, to get how many true pixels are on there. So you can see that that's the area or the fullness within the red box. So we could get number 3 out of all this noise by simply filtering out the fullness and looking anything below 80% should lock us into that image right there. And really what you want to do here is you want to take many different pictures and test these filters against all the different angles on the field. Gloworm doesn't quite have it yet, but the Limelight does have ability to take snapshots, and we can go look at that a little deeper later here as well, and then use those to test your algorithms. You can also program it to take pictures during the match. So anytime the driver hits the track target, you could store all these images back, and when the driver comes back to the pit, says, this is not working, something's not tracking right. Well, every time he hit the track target button, you're taking periodic images, and you can test what he was seeing on the field in case lighting conditions did change, say a skylight in a venue moving along. Any questions up to this point for the different filters? Is there anybody on the mic? No, nothing yet. Okay, moving on. So I kind of alluded to before, and that's these filters right here. Is I want to go back to the Limelight because it's a little bit more stable on this particular part of the demo. Is I kind of said, well, there's ways to look at this without using a robot. And we set up our laptop with the IP of what the robot would normally land on. When we install all the software for VS Code on our computer, you'll see in your local drive or in your public drive where all the WPI installs a tools folder. And then in that tools folder is all where the drop downs when you launch tool like Robot Builder, Alt Light Viewer, and the other different utilities we use for Shuffleboard and the Smart Dashboard. But this Outline Viewer is what we're going to look at right now. And we're going to set this to server mode because we want our laptop to be the server because there is no robot on this network. And what you're going to see here is what the Limelight is publishing. You can see that right now it is live. The latency is roughly, I believe that's 4 milliseconds. So this is updating. There's just no targets being found because the light's not on. We're on pipeline 0 probably right now, our driver mode. So we go over to limelight.local 5801 for the Limelight. We can see, sure enough, it is on driver mode because up here is pipeline 0. But we are going to likely control this with our robot. And I'll show you some code that we've developed over the past years to create a Limelight library. And the same can be done with the Gloworm. And I believe there's some work being done in the open community on this as well. But I can go ahead, and what I would do with the robot is I would set my pipeline, pipeline 1. And you can see right in the background, it is starting to track targets back here. So as we're looking at this, I'm going to switch over to one of the other demos. Those diagonal objects should be familiar with anybody that was in the game 2 years ago now. I keep on saying last year, but we're kind of an extension year here. These would have been the cargo ship targets or the rocket ship targets on there. And the object here is which set of 2 do you want to find? So you can see it's kind of jumping around trying to figure things out again. And that's going to be over here in the contours filtering. We can see that this year, well, we're kind of halfway through there. And that's the thing about this. We have the same green lights, the same tape, reflective tape every year. So really the thresholding doesn't change much year after year, especially if your venue's always very consistent. Record these numbers, save them. You can hit this little download button and all this is exported into a text readable file. And you can reload these things and move them to different folders and make backups of them. And we can look at that if anybody wants to look at those deeper later on. This contour filtering, what it's doing is it's looking for dual targets. Everything's wide open right here, but what it's really, we haven't done is this intersection. Maybe we want 2 targets that are always intersecting above, and it's having a hard time blinking back and forth. Let's kind of narrow some of this. It's too much. Well, here, how about that? So what we're seeing here is we have a ratio that's really wide and not tall. And it looks like it's trying to blink into a really tall aspect ratio. So we want something that's to get rid of those tall aspect ratios. We want something pretty small here in this. It's tall when we looked at the other sample was a small number. And these are not linear. These are logarithmic or something. And maybe what I need to do is just cover up that bottom one. In fact, that wasn't part of the game anyhow, so there would be ways to filter that out, but I did not plan for that here. So
Let's see, Corey, we got a question in the chat here.
Yes.
It's how much the Limelights do you usually cost?
The Limelights are retailing for, is it $4.99? So they are reasonably expensive, but out of the box, they do work and work well. So you you're paying for that support. I can tell you for sure that this angled option of where it intersects did not work the day that the game was released, but by Monday they had a patch already out for it. So now we're jumping between left and right because we're looking for here is the largest, and maybe we want our robot to always default to the leftmost angles, or maybe the game says we want to find something that the vertical below it, so we want to make sure we can. So another filtration options that are here. And then I'm sure that a follow-up question to that question, or that follow-up answer to that question, it would be is how much is the Gloworm? Right now, the Glowworms are listed on their site for $125 for the hardware. It is a beta price, so you're going to get the 3D printed case. As for the legality of using them on our robots, I haven't heard anything either way on that one, just for the fact of availability. And that's always one of those things that a major retailing site must have enough on hand for teams to purchase. So I do not have an answer for that one. So that one's still in debate. Another thing I'd like to demo, because we have approximately 15, 20 minutes here, is we had developed our library. You can see on here, there's lots of information here, TX, TY. In fact, let me go see show you what these are doing here. So let's say we lined up our robot, and this is exactly our scoring position. When we hit vertical above. When we hit fire on our robot, this is what actually scores the part into the goal. Well, you can see this crosshairs in the middle of the screen. We can now go into output and calibrate our XY. And what that does is moves it from the 0, 0. And if we look at the XY, we can see that currently the target is -4 degrees and +16 degrees. And these are actual degrees, not in pixels. A lot of times when you have your custom pipelines built, you get a number of pixels across, but this already accounts for the field of view of the camera and gives you a number of degrees to the target. So we can see when we hit this calibrate, it now brings the X to the center of the target. And if we look at what's coming back on our network table, we're seeing that where X is 0, Y is 1.5. We can hit calibrate again, see if we can't move that up and get still a little bit low. Oh, that's to the power of E, so that's virtually 0. I didn't see that part of it. So virtually 0. So now we can get this, we're getting this data back to our robot. We have to find a way to read this network table. Now, C++, Java, LabVIEW, Python, there's ways to read the network table. And the Limelight website, as well as the Photon Vision and Gloworm, they all have sample codes of how to do it. And every time you create a variable or you need to read a variable, there's a string of documentation or a string of text that you have to type in for your program. We created a Limelight library, and other teams have created them as well. Ours is a little bit manual for the installation, but I can go ahead and show you our kind of process of building a brand new from scratch robot. And this is our process. First thing we do is we're going to launch up VS Code. This is actually the Photon Vision code that's up right now. And if you've been into my other classes, we like to use the robot builder. Give this a quick name, create a project. Now we're going to create a quick subsystem here. We're going to call this Vision. We created an add-on profile for Robot Builder to drag this in. This is all on our GitHub site, and I'll show you that here in a moment. We just drag a Limelight into there and make a command of use Vision. And sure, we'll make that require Java. We're not going to come back to that. Java start demo. And once these little timer, this little wheel here grinds out, this is going to have some errors. And the reason it's going to have some errors is because there is one manual step that we need to take. We can see in our Vision subsystem that it's creating a Limelight object. Creating this Limelight. Our library, you can pass in the name of it. If you're going to have more than one Limelight, you can rename them. But you can see that it's looking for this import, and this import does not currently exist. And that's where the error is going to be up there. So we're going to go over to our GitHub. Sometimes the easiest way to find on something on GitHub is GitHub and then our team name, Kansas City Gearheads. And this isn't the most organized GitHub in the world, like many first teams that are basic, but we're going to go look at, I'm going to go look at our 2019 Jupyter, and I'm going to download this whole source. I've already done this earlier today. If I go show a folder here, you're going to see, extract that. Must have deleted it. If I just drill through here, we're going to see in the Java folder a folder called OI, and that's our Limelight library. I'm going to copy this. And there are the errors up there. And I'm going to click on this Java folder and then Review and Explorer. And under Java, I'm just going to paste this in here. And now you can see that our project now went happy because this import now exists in our project. Now, we did have a Marvin repository kind of working at one time, so we could add that to the build Gradle and not have to do this manual process. But none of us are expert at the GitHub and maintaining that repository, so it still remains a manual process. But I believe some teams out there have created some pretty good processes here. So this Limelight object exists. In our Vision, we're going to create a quick method here. We're going to return a Limelight object.
Another question here for you, Corey.
Yes.
Do you have any recommendations for IP network cameras? Aside from the Limelight, obviously. But
The only one we use is this access camera that I kind of showed here. And we use that very successfully. I don't know if they're necessarily even available. They're tougher to find. So I do not, but I would hope that maybe somebody in chat has some options out there. Kind of educate us all a little bit. What's that called up there? Limelight 1. And here's the great thing about now this object is inside here, and if you look at all the sample code, you're going to have to know, and we can go look at our library here, all these different network table calls. So if you want to get the TX, or what TX is, you get network table get entry, and you have to give it the key name for that network table. Well, TY and TX and TA aren't very user readable. So we created these methods: get degrees vertical to target, get target area. So what we can do here is I'm going to go into that command that's supposed to get this here, and maybe in my execute, and this is using the old command-based system. Oh, private. We need public. Sometimes typing and reading is hard. Typing and talking. Get limelight dot, and here we don't need to know that TY. We can get degrees rotation to target, and maybe we set that to a variable. So now we can use this in our code to control the, maybe autonomously, the direction of our robot to turn it. Other things we can do here is, I kind of alluded to that pipeline where we can switch the number. There's also a call to that where we can go robot dot vision, get the limelight again, and we can set things like camera mode, and that's where you look at the API on the website, and a 0 is drive or normal mode, a 1 is drive mode, a 2 is this mode. Maybe if you want that picture in picture, you could set the stream, and these things are, you'd have to revert back to that. But having these methods here for us, we can set cam mode, and we can go look at that. And what is it expecting? Expecting a variable type cam mode. And if you kind of looked at the control mode, all these different modes are here. So LED mode, if you want the lights on or off, cam mode, vision or driver, 0 or 1. So cam mode dot driver. And now that's a little bit more user readable than remembering that a 0 is driver and a 1 is pipe or vision. Same thing here, but we don't, and I said, like, we kind of allude that we do not use that, just for the fact that you'd have to make sure you switch back and forth. We go ahead and set pipeline, and maybe when this vision is happening, we want pipeline 1, but as soon as the vision is done, we can go ahead and set it back to 0. So the driver now has full view of it.
So in regards to your camera question earlier, just some research here on Chief Delphi. It looks like the Axis camera is the best IP camera as far as an IP camera goes, partially because of the latency and your cost point. So really there's no rule that would point against any sort of a camera that would say you can't have it. But when you're looking at network cameras, cost point becomes a huge, huge question, because you're looking now into higher end cameras that also reduce your latency. So like according to this here, it says that the Axis cameras tend to have a lower latency for an IP camera. And it says it can see some with 3/4 of a second of delay. So, which is pretty decent for what a camera is. But
the other thing with the IP camera is then you still need a processor. Where are you going to do that processing on? You can use a tool called Grip. It's part of the FRC WPI. It's on the WPI docs site on how to use the program Grip. You can run that feed to your driver station, process it on your driver station, and then send the data back over network tables to the robot. And that's where this Kangaroo mini PC came into effect when we were using Grip. This is a Windows 7 mini PC. We installed an external fan in there because this is just a passively cooled device. And we brought in a USB camera an IP camera to that, and then you can use GRIP, which is graphical real-time image processing. It's a drag and drop application, which if you want to learn a little bit about how the vision pipeline looks, it's an awesome application to use. You can plug your webcam right into your laptop and do a lot of learning that way on how these different filters work. And you actually have to build the filter tree. I don't have a quick sample I can pull up on here right now, but it's definitely an option. You just have to make sure you fire that grip up on your driver station so it's running. But it is bandwidth. The last couple of years, they shrunk us down to that 7 meg down to 4. You know, and when we actually, let's show that USB camera on here. We didn't do that. Just lost my power. So I'm plugging into a USB camera right into the Limelight. Thank you. Wait for that to boot up a little bit here. I closed Outline Viewer, huh? Looks like the camera's back up again. You can see when we add a USB camera that these two images are stitched side by side. This does double the bandwidth. This image is now goes from a 320 by 240 to a 640 by 240 image. So it does use more bandwidth. So what you can do is go ahead and set again, since I ain't got a robot in front of me, we can set the stream from 0 to 1. And what that does is it goes picture mode. So we got the main camera, the Limelight cameras here, and then the USB camera in the bottom corner, and flip between to number 2 to flip those two images back and forth. And that's one way to get 2 camera feeds back to your driver station with using only 1 pipeline worth of bandwidth in that stream. We did that where on our deep space robot had 2 Limelights and two USB cameras. Right, one USB was plugged in the Robo Rio as a simple driver camera. The other one, the Limelight and USB, were our forward drive and reverse drive. So our driver would flip the mode and make forward actually be reverse. It would flip all the directionalities because our robot had 2 forwards. Both the ends were considered forward at any particular part of the game. And that would automatically flip our cameras from the picture back and forth between what he's doing. One thing we do is we should look at here is this 5801. And mind you, everything I'm doing here with the Limelight is also somewhat possible with the Gloworm. If I go to 5800 for the Limelight, this is purely the stream time. What time do I got? Wrap it up. Okay, this is purely the stream. So we could go ahead and zoom in here and maybe fire up, and this be on our driver station on the second monitor. Or I want to fancy this up here. Some of our mentors created this web dashboard that we have our sponsorships and scrolling marquees of our vision system going on here. So if there are no other further questions, I thank you here. And if you have any other questions, do reach out to us on our grandcitygearheads.com as well as grandcitygearheads@gmail.com. I'd be happy to talk further.
I just found one quick thing too. They actually don't make that Axis camera anymore.
They don't make that.
They do not make that exact model. The closest one is around $300.
All right.
All right. I want to go ahead and thank everybody for attending today. This event, the Jumpstart by Medtronic virtual event. Presentations will be posted on the Jumpstart page at www.jumpstartrobotics.org, and they should all be posted by Monday. Again, check out the website, granitecitygearheads.com, and go ahead and send them an email if you wanted to connect with them further. Well, this concludes our session today, and we hope you enjoy the rest of your afternoon.